Good morning. These are our properties notes. These will go in on page 9 of your notebook, just after the notes you just took on translating expressions. So these properties you are aware of, you know how to use. It's those names that we sometimes forget. So our commutative property of addition. The key is that adding is the operation. So when two numbers are added together, key, the sum is the same regardless of the order. So this is the one where we can put them in either order. We can mix them around and it's going to be the same thing. So you should have highlighted those three pieces. So you're going to need a highlighter, and I made sure you all had one. If you are at home and you don't have a highlighter, and you can use a pencil and underline if you want. So we have that. You'll also need a pencil. So if we look here, it's the order that switches. So see how the 6 is first, then the 3? And then over here, it's the 3, and then the 6. We know those are the same. 6 plus 3 is the same as 3 plus 6. No matter which way you put them, it's going to be 9. Same thing with the 7 and the 10. Whether you have the 7 first or the 10 first, it's going to be 17. Same thing with variables. A plus B is equivalent to B plus A. So there's our commutative property of addition. So I like to draw the little arrows to kind of show that switcheroo. So it's kind of that helpful symbol that'll help us as we go through. Speaking of commutative property, that one also doesn't matter the order. If you look there, the order. But this is commutative property of multiplication. So that's when two numbers are multiplied. The product is the same regardless of the order, which we are also aware of. We know that 4 times 6 is the same as 6 times 4. We know that. If you want to stay consistent, we can draw little arrows for our top example. That's fine. Same thing with variables. A times B is the same as B times A. Normally, we write it like this one because it's in alphabetical order. We try to keep our variables in order. But to evaluate, it's going to be the same either way, if it's all multiplication. Associative property of addition. Now notice we're still talking about addition. You can keep the same color, that's fine. I'm going to mix it up a little bit. So it's still addition. It's not just two numbers anymore. And commutative property can work for more than two numbers. But associative property of addition is when there's 3 or more numbers that are added together, and it's all addition, all of it. You can add negative numbers as long as you keep the negative with your number. The sum is the same regardless of the way they are grouped. The grouping, so the key here are these parentheses. The parentheses are moving. That's the key. So if you notice here, we have 6 plus 1 first, and then we have plus 5. Order stays the same. So 6, 1, 5, and the next one is 6, 1, 5, but the grouping symbols are around the 1 and the 5. We're going to get the same answer either way. And why we use associative property is that sometimes it's easier to group two numbers together with mental math and then add it to the third one. It just kind of helps out making things go a little quicker. So that's our associative property of addition. So that one deals with parentheses. So I'm going to draw giant parentheses around that to help us to remember. Same thing with variables, as long as it's all addition. A plus B first, then adding C is the same as B plus C first, and then adding A. So the next one, we also have associative property of multiplication. Same idea, the order is going to stay the same. It just depends on our grouping symbols. So I'm going to group that 8 times 2 times 3 is the same as 8 times 2 times 3. See, for this one, if we do 8 times 2 is 16 times 3, you may have to set it up vertically, like 16 times 3. No, I know some of you can do that mental math, that's fine. If we do it this way and do 2 times 3 first, which is 6, 6 times 8 is 48. That's still a math fact, so it kind of helps for the quickness if you actually group the second two together faster. So that's where associative property is helpful. Next one. Oh, I forgot to multiply. That's multiplied. When 3 or more numbers are multiplied, the product is the same regardless of the grouping. So those are those parentheses. All right. Our next one is our distributive property. This is my personal favorite property. So for this one, it's when we have multiplication, that is key, outside the parentheses to each value of inside the parentheses. Now inside there can be operations. There can be addition, there can be subtraction. Usually those are the only ones in there for this to work. And we are multiplying that outside number into everything on the inside. So this would be like 4 times 6, and this would be 4 times 3. So we distribute it in with multiplication. You can write it out separately, but we should be simplifying that. So 4 times 3 is 12, so we can write the 12 because we know what that is. So we have a few options there. Same thing here, just like here, we got 2 times 7 is 14, which they wrote. 2 times 4 is 8. 2 times -5 gives us a -10. That's how it goes. Same thing with variables. Same things with variables. Y times D. We just write it as YD, which is still Y times D because the variables are right next to each other showing multiplication. And then Y times F would be YF right next to each other. Now I'm going to give you a little extra example here at the bottom. I'm kind of running out of room here. All right, well, squeeze it in. So if we have, let's go with 6 minus 4 times 3. Now, I know you can do order of operations, but that's still showing distributive property. It's technically a combination of distributive property and commutative property of multiplication. It's just on the other side. So we can distribute that 3 still into our parentheses from the other side. It's the same thing. 3 times 4, 12. We know that. Or you can look at it as 3 times -4 is a -12. And then 3 times 6 is 18. So we would have 18 minus 12. And then you could simplify from there. Usually we have variables mixed in, and that's when distributive property is helpful. Because I would agree, order of operations would be a little bit easier there. All right, next side. Here we go. Identity property. Identity is like who you are. So it's kind of like a helpful thought as we go through this identity property of addition. So again, we're adding here. The sum of any number and 0 is the original number. So sum is the addition. That is key. And if you add 0 to it, it's still itself. Its identity stays the same. So here we have 4 plus 0 is 4. And I'm going to focus in on the plus 0 because that is the key. Anything plus 0 is itself. A plus 0, still A. So that's the idea there of that identity. Their identity, their number stays the same. We have another identity property. This identity property goes along with multiplication. So the product, the answer to a multiplication problem, of any number and 1 is the original number. So if we multiply, it's multiplying by 1, leaves the number as itself. So 4 times 1 is 4. 2,000 times 1, 2,000. X times 1 is just 1x. Look at that 1x is sitting right there. X. Additive inverse of a number. Additive inverse of another. Inverses are ones, I always like to think of them as opposites. And look, it says here, when opposites, so additive inverse of a number is like opposites. It's when they're added together and the sum is 0. Numbers that cancel out when we combine them. Opposites. Opposites combined, giving us 0. This helps us to solve equations. So if we have 16 plus a negative 16, we get 0. Notice their opposites combined to give us 0. 24 plus a negative 24, 0. Which also means that a plus a negative a gives us 0. So that's our additive inverse. It's like an opposite. Multiplication also has an opposite. Our multiplicative inverse of a number. Yes, I said that correctly. Multiplicative. Try to pronounce that. Multiplicative inverse of a number. It's when you multiply a number by its reciprocal. It's kind of the same idea of opposite, but it's not really an opposite. But our reciprocal is when we flip our numerator and our denominator. And actually the definition would be to get the answer of 1 when we multiply. So this 3/1 reciprocal is this 1/3, which when we multiply those, it does give us 1. 2/100ths reciprocal is 100 halves. And if we multiply those together, we still get 1. And then 1/y, its reciprocal would be y/1. When we multiply those, we still get 1. And that y/1 is the reciprocal of our 1y. And finally, multiplication property of 0. Now, multiplication had a property with 1, our identity property. It also has a property with 0. Multiplying by 0 gives us 0. I know you've used this one. See, we've used all of these. We are aware of how they work and we use them, but we don't always remember what they're called, and we're going to need to. And we'll talk about that more in class. So we have 6 times 0 gives us 0. 0 times 19 still gives us 0. X times 0, still 0. All right, so glue this in, bring it to class.